Good evening. Today we are going to discuss an important topic in calculus, that is derivatives or differentiation. But before that, let us solve this particular limit. Can we take limit in the first step? The answer is no. Why? Because we get 0 by 0 form. So what we do is divide numerator and denominator by x. Is this allowed? Yes. Why? Because x only tends to 0 and x is not equal to 0. Okay. So this is nothing but limit x tends to 0. You have to divide each term. So x upon x is 1 in the numerator. And which is the second term? I'm sorry, x square upon x. That is x square, not x. So x square upon x is x plus sin x upon x. Let me see. Yes, sin x upon x. What about denominator? X cos x upon x is cos x. Okay, minus 3 sin x upon x. Now, to take the limit means to replace every x by its limiting value, which is 0, or use standard limit. We have discussed this. Limit x tends to 0, sin x upon x is 1. What about denominator? Cos 0, which is 1, minus 3 into, again this is standard limit, its value is 1. So 1 upon 1 minus 3, that is minus 2. So final answer is minus 1 upon 2. Okay. So let us start. See, in just 60 to 70 minutes, it is impossible to cover the topic derivatives, but I'm going to explain the basic things. Initially, I will tell you the definition of derivative. Then in physics, you should know derivatives of standard functions, like what is derivative of sin x, what is derivative of log x, what is derivative of sine inverse x, etc. There are simple rules of derivatives. I will just tell you those rules. If you pay attention, rules can be remembered easily. Then I'm going to tell you two important things. One is interpretation of derivatives. That is the most important thing. And secondly, physical significance of derivative. So let us begin. Suppose x and x plus delta x. You have used delta x in physics. Delta x denotes small change in the value of x. Okay. So suppose x and x plus delta x belong to the domain of the same function, and if limit delta x tends to 0, f of x plus delta x minus fx upon delta x, if this particular limit exists. It is not compulsory that this should exist, because we have seen, I think last example which we did yesterday, limit, our conclusion was limit does not exist. But if this limit exists, it is called as derivative of the function y equal to fx with respect to x, and it is denoted by f dash of x. I repeat, I will explain logic of this also. Why to take value of limit of this function only. That also we are going to discuss. But first let me define what is derivative. Suppose x and x plus delta x. What is delta x? Very small change in the value of x. Suppose both of them belong to the domain of the function. And if limit f of x plus delta x minus fx upon delta x tends to 0 exists, then it is called as derivative of the function y equal to fx with respect to x. How to read this? F dash of x. If derivative of a function exists, function is called as derivable or differentiable. If derivative of a function exists, don't write this, because I have already uploaded notes for the same. So function is said to be derivable or differentiable function. The process of obtaining derivative of a function is called as differentiation. Differen, not CIA, TIATION. Differentiation. So what is differentiation? It is the process of obtaining derivative of a function. Now this is also called as derivative from the first principle. Finding derivative using this method is called as derivative from the first principle. Now, in some cases, the small change delta x is denoted by h. So in that case, what will be f dash of x? It is limit h tends to 0, f of x plus h minus fx upon h. What I have done is I have replaced that small change delta x in x by h. Suppose this limit exists. Suppose this limit exists. Which one? Limit h tends to 0, f of a plus h minus f of a upon h. Then value of this limit is denoted by f dash of a. So what is f dash of a? It is nothing but value of derivative, rather derivative of the function. Which function? Same function, y equal to fx. At which point? At x equal to a. Okay. Again, what is derivative of a function? Suppose x and x plus x, rather x and x plus delta x belong to the domain of the same function, and limit delta x tends to 0 of f of x plus delta x minus fx upon delta x exists, then it is called as derivative of the function y equal to fx with respect to x. The function, if its derivative exists, is called as derivable or differentiable function. The process of obtaining derivative of a function is called as differentiation. Now we are interested in obtaining derivatives of standard functions. Basically, which functions are called as standard functions? 6 trigonometric functions: sine, cos, tan, sec, cosec, cot. Then inverse trigonometric function. I'm going to explain concept of inverse function also. Actually, once I have already told you about it, but today I will repeat that. Then x raised to n, log x, a raised to x, e raised to x, all these are standard functions. Now, if f of x, don't write this, if f of x is sin x, then its derivative with respect to x is nothing but cos x. Now don't ask me how. If you want, you can Google this, or you can refer to textbook, because this is there in the syllabus, but this topic will be taught in detail in second semester. If function is sin x, you have to just remember at present that its derivative is cos x. See why I am saying with respect to x. If function is sin t, f of t, then it will be f dash of t cos t. Simple. Okay. Now this notation is not convenient. Every time we have to say if f of x is sin x, f dash of x is cos x, and for this there is one notation given by this German mathematician Leibniz. So Leibniz notation for derivative. It is interesting and can be understood easily. Just listen to me. Suppose y equal to f of x is a differentiable function, means what? Its derivative exists. Suppose x changes to x plus delta x. So in that case, y will change to what? Y plus delta y, because y depends on x. So I will say y plus delta y. is f of x plus delta x. This is not at all difficult. See, suppose y is area. Area of a circle is a function of radius. If radius changes, area will also change. And that is what I am saying. Suppose x changes to x plus delta x. As a result, y will change to y plus delta y. Okay. Now from this, tell me what is delta y? Delta y will be f of x plus delta x minus what? Y. Bring this term to RHS. I hope you get this. But what is y? Instead of writing minus y, I will write f of x. Why? Because y is given to be f of x. Next step is important. Divide both sides by delta x. Is division allowed? Yes, because delta x is a small change. It is not zero. It only tends to zero. Now take limit on both the sides. So limit delta x tends to 0 of what? Delta y upon delta x. On the right hand side also limit delta x tends to 0 f of x plus delta x minus fx upon delta x. Note that right hand side is nothing but f dash of a. I have begun the lecture by using this only. This is called as derivative of the function f with respect to x, that is f dash of x. Now Leibniz denoted the limit on left hand side by what? By dy dx. So in some cases you can read this as dy upon dx, but note that this is not d into y upon d into x, so do not cancel dd. I repeat this. Leibniz denoted the limit on left hand side by what? How to read this? Dy dx or dy upon dx. Note that delta y is a small change in y corresponding to small change delta x in x. So this is called as incrementary ratio. Increment delta y is an increment in y, change in y. Delta x is an increment, change in x. So this is incrementary ratio. So if you take the limit of that, you get dy dx. So dy dx is nothing but f dash of x. Now, for the sake of convenience, we will write this as ddx of y. This is not given in the textbook as such, but I can call this as an operator. ddx is an operator. What operation does it perform? It performs the operation of differentiation, right? So what is ddx of y? It is derivative of y with respect to x, which is nothing but f dash of x. See, the proof is not required. I'm not going to repeat the proof. If you haven't understood the proof, just forget it. Remember Leibniz notation. Okay. So I just explained the proof so that you will not think of cancelling dd. That is absurd. That is ridiculous. Cancelling dd to get y upon x. This is ddx of y. So ddx is an operator. I can call it as differentiator. And what operation does it perform? Operation of differentiation. Okay. Now, I need not say that if f of x is sin x, f dash of x is cos x. I will simply say ddx of sin x is nothing but cos x. Not only that, if I ask you what is ddt of sin t, it is nothing but cos t. Okay. So this is about Leibniz notation for derivative. Now we are going to just write, or I will in fact read derivatives of standard functions. At this stage, proofs are not required. Basically in physics, hardly 3-4 functions are required, like sin x, cos x. One important function is x raised to n. Now see, basics are important. Many students, they cannot differentiate between x raised to n and a raised to x. Lot of difference. In x raised to n, base is a variable, index is constant. Here base is constant and index is variable. Not only that, here base, what is the requirement? It should be greater than 0 and should not be equal to 1. Okay, this is called as power function and this is called as exponential function. So these are the standard results. Derivative of any constant equal to 0. See, we have just discussed that derivative of sin x is cos x. See result number 5. If I ask you, what is derivative of sin pi by 4? Sin pi by 4 is constant. Its derivative is 0. Derivative of any constant is always 0. Okay. Second function. Derivative of x raised to n is what? N into x raised to n minus 1. How will you remember this? This is index into x raised to index minus 1. Let me explain. I'll write that. So ddx of x raised to n is what? Index into x raised to index minus 1. So if I ask you, what is derivative of 1 upon x? Main job is to write the function in standard form. I hope you will not say apply formula in the denominator. That is absurd. Write 1 upon x in the form x raised to n. 1 upon x is x raised to minus 1. What is the answer? Index into x raised to index minus 1. That is minus 1 into x raised to minus 2. That is 1 upon x square. In physics, you will have to use this number of times. So what is ddx of 1 upon x? It is minus 1 upon x square. If I ask you to find what is ddx of root x? What is difficult? Calculus? No. Laws of indices. Basics. What is root x? X raised to half. What is derivative of x raised to half? It is half x raised to half minus 1. That is half x raised to minus half. And what is x raised to minus half? 1 upon x raised to half, that is root x. And that is why derivative of root x 1 upon 2 root x. I hope you are getting this. Otherwise, just remember the derivative of root 1 upon 2 root. Please do not draw any conclusion from this. I think I'm telling you this at least 10th time. If you want to learn derivatives, it takes at least 25 clock hours. So do not conclude that simple derivative of root sin x is 1 upon 2 root sin x. No, no, derivative is not that simple. I'm saying derivative of root x. Is this root x? No, it is root of sin x. So no. Then you will ask me that means derivative of this function does not exist. Yes, it does exist, but it is not that simple and we're not interested in discussing that. Okay. Yes. So what is derivative of sin x? Cos x. Derivative of cos x minus sin x. Derivative of tan x is not cot. Otherwise you will say sin to cos, cos to minus sin, so tan to cot. No. Derivative of tan x, sec square x. Derivative of cot x minus cosec square x. Derivative of sec x into tan x. Derivative of cosec x minus cosec x into cot x. Now these functions are simple. What is derivative of e raised to x? E raised to x. What will be derivative of a raised to x? A raised to x log a. In fact, from result number 12, we can obtain result number 11. How? Replace a by e. So answer is e raised to x log e. Log e is 1 because we are doing calculus. Base of logarithm is e. So it is simply e raised to x. What is derivative of log x? It is 1 upon x. So you have to remember these results. Actually, there are two more results. But before that, let me explain the concept of inverse function. Okay. It can be seen that there exists a function from A to B. Why? Because every element is associated uniquely. Now, if I ask you, is there any function from B to A? Yes, because every element is associated uniquely. From A, how to obtain B? Cube each element. Now, if I ask you, from B, how to obtain A? Will you say cube each element? No, it is the inverse process. What is the process which is inverse to cubing? Taking cube root. Okay. Cube root of 8 is 2. Cube root of 27 is 3. Cube root of minus 1 is minus 1. And this is called as inverse of the function. And we write it as f raised to minus 1. But please do not read this as f raised to minus 1. You have to read this as f inverse. Okay. And therefore, what is the inverse function of tangent x? It is denoted by tan inverse x. Listen to me carefully. I will tell you the difference between these three. This is tan inverse x. Tan inverse x. This is tan of, what is x raised to minus 1? 1 upon x. Tangent ratio of 1 upon x. And this is tan x raised to minus 1. That is 1 upon tan x, which is nothing but cot x. Okay. I'll give you specific example for inverse. What is sine 90 degree? Sine pi by 2? It is 1. So if I ask you, what is pi by 2? Your answer should be sine inverse 1. Okay. What is cos pi? Minus 1. Pi means 180. If you have done trigonometry, you will be able to appreciate this. Cos 180 degree is minus 1. Forget this. You had done this. Cos 60 degree. You had done this in 10th standard. What is cos 60 degree? Half. So if I ask you, what is 60 degree? Will you say cos half? No. Cos inverse half. Okay. So this is about inverse function. See, I'm explaining this because in physics, you usually use sine inverse, tan inverse, etc. So this is the list of derivatives of standard inverse trigonometric functions. I think you should remember result number 1 and 3. What is derivative of sine inverse x? 1 upon root of 1 minus x square. And what is derivative of tan inverse x? It is 1 upon 1 plus x square. Okay. I have mentioned all the 6, but you need not remember. See, anyway, you will be studying calculus in detail in second semester. But why are we conducting these lectures? Because maybe after few days, uh, you will have to find derivative of sin x, or you will come across expressions like integral cos x or dy dx. Just to have an idea, we are taking these lectures. Okay. You should not expect that you will be able to solve any sum on derivative. No. What is ddx of 1 upon x square root x? Write the function in the form x raised to n. Okay. So it is 1 upon x square. What is root x? X raised to half. What is 2 plus half? 2 plus half is 5 by 2. 1 upon x raised to 5 by 2 is x raised to minus 5 by 2. Now, what is derivative of x raised to n? It is n into x raised to n minus 1. That is minus 5 pi by 2. X raised to, what is minus 5 by 2 minus 1? Minus 7 by 2. Okay. Next one. Simple one. Y is given. Find out dy dx. Okay. After this, we have to say on differentiating with respect to x. Basically, this is sum of many functions. So what is derivative of sum? Sum of derivatives. I'm writing this directly. What is derivative of x cube? 3 x raised to 3 minus 1. That is 3x square. What is derivative of sine x? Cos x. Minus what is derivative of e raised to x? E raised to x, and derivative of any constant is 0, so we need not write plus 0. So this is the final answer. Okay, now we are going to discuss the most important part, geometrical interpretation of derivative. What does that derivative mean? What does it stand for? Okay, uh, can you tell me what is the slope of this line? You have done this in 10th standard. I'm asking you simple question. What is derivative of, rather, what is the slope of this line? Y equal to 3x plus 2. Very good. Most of the students are giving the correct answer. That's it. Yes. Slope of this line is 3. Now let me explain. Dy dx gives slope of the line. In fact, it gives slope of the tangent. I'm explaining that. Can you find derivative of this? Y is 3x plus 2. So what is dy dx? What is derivative of 3x? 3 into what is derivative of x? Derivative of x is 1. What is derivative of constant 2? 0. So 3. Now if you ask me, sir, why derivative of x is 1? Okay, I'll explain that. X means x raised to 1. Derivative is 1. X raised to 1 minus 1. That is x raised to 0, which is nothing but 1. So what is derivative of x? It is 1. So what is dy dx? What does derivative stand for? It gives slope of tangent to the curve. I'll draw the diagram so that you will understand it. This is graph of y equal to fx. Oh, I'm sorry. This is the point A, coordinates are a f of a on the curve. So f dash of x at x equal to a, that is f dash of a. What does f dash of a represent? It represents slope of this tangent. This is the tangent drawn to curve at a. Slope of this tangent is denoted by f dash of a. In general, see, this is given in the booklet. Dy dx, which is also called as gradient. This word is used in physics also. Gradient of the curve means slope, slope of tangent. Okay. Now, can you tell me equation of tangent? If you have done this in 10th standard, equation of line is y minus y1 equal to slope x minus x1. That is y minus f of a equal to slope. What is slope? F dash of a into x minus a. Okay. So this is nothing but the equation of tangent. Okay. You need not remember this, but if we know the slope, we can write the equation. Now one more thing. How will you describe this? This is line perpendicular to tangent, which also passes through this point only. This is called as normal to the curve. This is normal to the curve. Now we have done about a product of slopes of two perpendicular lines. If two lines are at right angles, product of their slopes is -1. So can you tell me slope of normal? Slope of tangent is f dash of a. So slope of normal will be -1 upon f dash of a. You can check. See, -1 upon f dash of a into f dash of a is -1. So what will be the equation of normal? Normal is passing through the same point. So y minus f of a equal to slope into x minus a. Okay. See, out of this discussion, you have to remember only one thing, that what is the geometrical interpretation of derivative dy dx? dy dx represents slope of tangent to the curve at a point on the curve. Okay. See, what is physical significance of derivative? Suppose a function given by y equal to fx is differentiable at x equal to a. If x changes from a to a plus h, then f of x will change from f of a to f of a plus h. The difference f of a plus h minus f of a is the change in f of x corresponding to change h in x. Why? Because previously it was uh, a plus h, now it is a. So what is that change? Change is h. The average rate of change, the average rate of change is obtained by dividing this f of a plus h minus fa by h. Okay. Now just forget this positive negative interval. Just read this. If we take the limit, then note that this is nothing but derivative, right? It is called instantaneous rate of change of the function f at x equal to a. Now forget about the previous part. You have to remember this. Hence we can say that derivative f dash of a measures the rate of change of f at x equal to a. See why derivative plays an important role in all the fields of uh, in fact in general any study, not only science but commerce, arts, everywhere, for the simple reason that derivative measures the rate of change. Okay, so derivative of a function is a rate measurer of the function. Let a particle be moving along a straight line. Now you should know this for physics. One student is saying, please repeat this. Okay, I'll repeat this part only. You're not supposed to remember the initial part of this. Just remember this, that derivative, see the cursor, derivative f dash of a measures the rate of change of f at x equal to a. Thus, derivative of a function is a rate measurer of the function. Just remember this statement for time being. Now, how this statement can be used? Let a particle be moving along a straight line such that its displacement s at time t is expressed as s equal to f of t. The rate of change of s with respect to t is ds dt, that is f dash of t, is called as velocity v of the particle at time t. Now, what is rate of change of velocity with respect to t? It is acceleration. So, can I say that dv dt? I think it is given. No. Okay. Just velocity is mentioned, but I can say that what is acceleration? See, acceleration is nothing but rate of change of velocity with respect to time. So, dv dt is nothing but acceleration. Okay. So what is the physical significance of derivative? Derivative measures the rate of change. In fact, we can use this concept to prove that derivative of constant equal to 0. I have already told you that derivative of any constant equal to 0. Why? Because derivative measures the rate of change, and constant is one which does not change. And that is why derivative of any constant is nothing but 0. Is that clear to you? Okay. Now, another concept. Consider the function y equal to x cube. What is dy dx? What is derivative of x cube? 3x square. Can I obtain derivative of 3x square? 3 is constant. What is derivative of x square? 2x. That is 6x. Note that 6x is derivative of 3x square. That is derivative of dy dx. That is, it is ddx of dy dx. Let me explain first. That is, this is derivative of a derivative. Now the convention is, do not ask me why, this is the convention. How to denote this? d2y by dx square. Do not read this as d square y, d square y by dx2. No, this is the convention. You have to read this as d2y by dx square. What is d2y by dx square? It is derivative of derivative, which is called as derivative of order 2. We have differentiated 2 times in succession. We have begun with x cube, derivative of x cube, that is first derivative 3x square. What is second derivative? 6x. Can we obtain derivative of 6x? Yes, it is 6. Can we obtain derivative of 6? Yes, it is 0. And note that 6x itself is derivative of derivative, that is second order derivative. In fact, there is one simple notation, y2. y1 means derivative obtained after differentiating once, y2 twice. So for 6 I can say y3, and for 0 y4. So how will you describe y3? Derivative of order 3, which is denoted by d3y by dx cube. What will be derivative of order 4? d4y by dx4. In general, derivative of order n is denoted by dny by dxn. The simplest notation is yn, derivative of order n. In physics, only second order derivatives are required. I think in 12th standard, you are going to study SHM, simple harmonic motion. In that case, you are going to consider second order derivative. I'm not sure, but d2 omega by dt square. d2 omega by dt square is basically ddt of d omega by dt. So this is called as derivative of order 2, second order derivative. Okay. See, this is also given. You can read this afterwards. Derivative of derivative, ddx of dy dx, that is ddx of f dash of x, is called second order derivative and is denoted by d2y by dx square or f double dash of x or y2 or y double dash. Okay. So this is about higher order derivatives. Now last and important part, rules of differentiation. If u and v are differentiable functions, what do you mean by differentiable? Differentiable means their derivatives can be obtained, defined. So if u and v are differentiable functions of x, and if y is u plus v, then dy dx is du dx plus dv dx. In fact, we have already used this. I'll explain. Second is simple one. If y is difference, what is derivative of difference? Difference of derivatives. I'll explain by considering examples, simple sums. Suppose y is x plus sine x. What is dy dx? You will say obviously it is 1 plus cos x. Not obviously. Here you have used one rule that derivative of sum, SUM sum, derivative of sum of these two functions is what? Sum of derivatives. That is derivative of first plus derivative of second. Derivative of x is 1. Derivative of sin x is cos x. And what is the second rule? Suppose y is difference, tan x minus e raised to x. What is derivative of difference? Difference of derivatives. So dy dx. What is derivative of tan x? Sec square x. Minus. What is derivative of e raised to x? E raised to x. Okay. So these are two simple rules, first and second. Now let me explain the third one. If y is u into v, that is product, then what is dy dx? First function into derivative of second plus second function into derivative of first. I hope you will not ask me What happens if we interchange u and v? Nothing happens, same thing. Why? Because u into v is same as v into u. See, even if you consider, you will observe on RHS that a function is multiplied by derivative of other. Every function gets chance to get differentiated. U derivative of second plus v derivative of first. Okay. I will consider one simple example. Y equal to x into sine x. So what is dy dx? First function x into derivative of second. So d dx of sine x plus second function sine x into derivative of first. Now, what is derivative of sine x? Cos x plus sine x into, what is derivative of x? It is 1. I'll explain this once again. This is the most important function. In physics, you usually obtain derivatives of simple functions x, x square, x cube, sin x, cos x. That's it. At the most, root x. Now, what is x? X means x raised to 1. What is its derivative? 1 x raised to 1 minus 1. That is 1 x raised to 0, which is nothing but 1. And that is why derivative of x is 1. So what is the final answer? It is x cos x plus sin x. Okay. Now try this one. Tell me your answer. Y is e raised to x into x raised to 5. So what is dy dx? E raised to x into derivative of x raised to 5, which is 5 x raised to 4, plus second function x raised to 5 into derivative of e raised to x, which is e raised to x. Here derivative part is over. If possible, take x raised to 4 e raised to x common to get in bracket 5 plus x. Now let me ask you this. See, this is mathematics. Can you tell me derivative of sine square x? With limited knowledge of derivatives, you should be able to obtain derivative of sine square x. Try. See, this is just the beginning. Don't generalize any result. The derivative of x square is 2x. So derivative of sine square x is 2 sine x. No. I hope you can differentiate between two functions. X is algebraic, sine x is trigonometric. Still, I have asked you to find this. Means you have to express sine square x as what? Sine x into sine x. Now use product rule. First function sine x into derivative of second sine x, rather ddx of sine x, plus second function sine x into derivative of first. Have I said that two functions should be distinct, different? No, u can be equal to v. So sine x. What is derivative of sine x? Cos x plus what is derivative of this sin x? ऐसा थोड़ी होता है ये sin x वो sin x. Derivative of this is also cos x. Okay, so sin x into cos x plus sin x into cos x, and therefore what is the answer? Derivative of sin square x is 2 sin x into cos x. Now the last rule is quotient rule, can be remembered easily. If y is u upon v, then what is dy dx? It is denominator into derivative of numerator minus numerator into derivative of denominator upon denominator square, provided denominator is not equal to 0. This is called as quotient rule. Let me explain. See, I write quotient rule once again. If y is u upon v, then what is dy dx? It is v du dx minus u dv dx upon v square. Okay. Can you tell me what is derivative of tan x? We have just discussed that derivative of tan x is sec square x. Just give me a minute. Now we will try to obtain derivative of tan x using quotient rule. Because what is tan? Sin x upon cos x. This is interesting. We are verifying this. Now, what is quotient rule? V, that is denominator. What is denominator? Cos x. Let me explain. Into du dx, that is derivative of numerator. What is sin x? What is derivative of sin x? It is nothing but cos x. So I write cos x minus u means numerator. So minus sin x into dv dx, that is derivative of denominator, because v means denominator. Derivative of cos x is minus sin x. Okay, upon v square, that is denominator square, which is cos square x. Now this is interesting. What is numerator? Simplify. Cos square, minus minus plus. So numerator is cos square x plus sin square x, which is 1. 1 upon cos square x. I hope you know this. 1 upon cos is sec. And for that sake, I can write this as sec square x. Yes, derivative of tan x is nothing but sec square x. Is that clear? So I have explained everything what is required for physics. Remember, I have just explained derivatives for 45 to 50 minutes. If you want to be thorough in this topic, then you will have to study this at least for 25 to 30 clock hours. But in today's, rather after today's discussion, I hope you will understand the meaning of dy dx. It is derivative of y with respect to x. What is the interpretation of derivative? Slope of tangent. And what is derivative? Physical significance. It measures the rate of change. So you have to remember this. Okay. So that's it for today.